A very good evening to everyone, and also like good morning to few of the folks who have started, joined from Central Time Zone as well. So let me share my screen and also just a minute. All right, just let me know if my screen is visible, guys.
Able to see.
Great, thank you. Yeah, once again, a very good evening and good morning to everyone whoever joined. So thank you for joining the session first of all, and let me give a short introduction about me. Yes, even though Arumugam has shared few details about me, I'm Rajesh. I am working as a senior technical lead in EPAM systems. I do have more than 12 plus years of industry experience in IT. So I have good knowledge in both big data technologies as well as cloud. So more focused on cloud AWS. So this has been my background. So today the topic is very very simple and more powerful. So today we are going to see how data engineering in cloud is used and couple of use cases that we are going to see. So for that I have prepared a deck for that to understand this, and also we will be going through couple of AWS services in directly AWS management console as well. So I'll be taking you through all the practical things whatever I'm just going to share you, what about the services that we are going to highlight as per the session requirements. Fine. So here we have like couple of people who are from different background, like maybe a development or testing or from DevOps or even from production support. So we as an engineer, maybe we can call them as data engineer, how they can transform their career to a cloud engineer. That's very important. So data engineering being a powerful thing in the market nowadays, so that how we can leverage the cloud computing in data engineering is very very important. So as we know, there are like couple of multiple cloud service providers are there in the market, like being like Amazon, AWS, Microsoft being hosting as Azure, and even Google as a one of the big competitor for hosting GCP. So there are like good opportunities being popped up here, but today we are going to focus fully on only one particular cloud service provider called Amazon Web Services. All right. Yes. So let me go through the PPTs now. So I'm just going to share the full mode. Yes. So why are we going for cloud particularly? So as there is a huge demand to migrate all the data or even the database or any re-engineering projects are being currently happening in the IT market, just to ensure that we are satisfying three critical things. One is the design, and the second thing is budget, and the third one is the availability of data or the data demand, I can say. With all these three things, when it comes to satisfy any cloud service provider, we can just simply go on and just take a stock of having all the necessary services to work on. Now, as you know that AWS provides more than 100 plus AWS services are available in the market currently as of 2023. Right away, you are going to see, you are just seeing like upfront, like there are like couple of AWS services are there. Like when it comes to application, we have like SQS, Cloud Search, SES, Upstream, and when it comes to networking, we have like Route 53 VPC. Likewise, AWS fixes couple of division across multiple application. So let's say like when it comes to networking background, we have like VPC, IAM roles, policies, and others. For gaming, even we have specific services which are in the market under AWS as well. So there are like couple of things here. Right away, we are not going to detailedly see all AWS 100 plus services in today's topic. From that, we are going to pick only the best 10 services which are used currently in our day-to-day life in data engineering project. So those 10 most used AWS services are they here, guys, right? And at the end of the session, not only like explaining all these 10 beautiful AWS services, I will also be explaining a use case that is very very simple data engineering project that can be still, you can even do it in your own laptop as well. We don't want to worry about hosting any for physical or virtual servers from any companies or that you go. So right away, I'll just start my most used AWS services list, starting from S3, EMR, EC2, Lambda, AWS Glue, Athena, Step Functions, Redshift, SQS, Simple Queue Service, and then followed by data migration service or migrating services that you call. All right. So now let me go to this, mini mod that I can even, pop up to the navigate to the AWS Management Console as well. So let me go to the next slide. So here, if you see, first of all, the first in the list is Amazon S3. So basically, what is S3? As like in the name, we call it a simple storage service. Sorry, it is as like many people who are working as a big data engineers, they come to know HDFS, Hadoop Distributed File System. Likewise, Amazon also provides a beautiful file system where we call them as S3. It called as simple storage service. Rather than calling it as a file system, we always need to mention it as S3 as an object storage, because what are all the files which are going to store in S3, it's going to treat it as objects, not as files. Why? Because it can take any kind of data, that maybe like you can have a text file or any data which comes from CSV, Avro, JSON, Parquet, image file, or even videos that can even accumulate in the S3 as well. One major thing about to know in S3 is how it stores the data. So we should know what is S3 bucket. Okay, bucket is nothing but it is basically a container where all your storage is going to happen. So we can create n number of buckets in our AWS management console, and we can even set our bucket policy to enable access control list, like who to read, who to write, who to control the buckets as well. So these are some of the advantages as well, I mean, like main features where many companies are relying on, like, to have a backup of your data on, for most importantly, storage. And for data archiving, even when we are able to create a simple data lake, obviously without S3 we will not go move forward, right? Even for disaster recovery, you can even keep this S3 as one of the beautiful recovery system, such that there is a 99.999% followed by nine nines data available will be there. All right. Yes, let's not waste our time explaining more theoretical. Let's go to the management console. So I will go here. Maybe before jumping into this practically, right? So I will tell you a couple of things before jumping in. So this login, right, it's very very simple and straightforward, guys. So you can even just simply create your account with your own credentials. Just a valid email account is absolutely necessary to open an account. No casting required. Only at the time of setup you need 2 rupees to register. After verification of your profile and registration, the 2 rupees will get credited back to your account. So for this, right, for even for my own YouTube channel, RK Data Labs, I'm just completely, practicing all my modules, all my topics, everything in my own laptop itself. So don't worry about like only like infrastructure is a big concern here. So keep rocking, keep, you know just register your account, your own account in your machine as well. Okay, without wasting time, let's move on to the first list, that S3. So as you go here, just type it here, S3, and you can able to see the necessary service listed here. So here at the left side of the Explorer, always you see like all the sub modules which is showing here. And also like at the main side of the Explorer, you can able to see what are all the things that you can do. Simple, I'm just going to create a bucket, and you can able to see like there are couple of regions available. Maybe I'll just give you a quick snapshot of what is this regions about. In AWS, we call them as AZs, which is nothing but availability zones, which is nothing but a physical data center where your all your data is going to store in a particular place. So AWS divides all the data centers across the continents, like maybe like they have United States, or even from Asia, or even from Australia. Like there are about 31 AZs, I mean regions are available as of now, right? So from which you are able to select one particular region to store your data as per the policy. So now what I'm going to do, I'm just by default going to select US East 1 as my region, and then I'm going to give my bucket name called.
I'm sorry to interrupt. When we
Yes.
choose this region, is there any cost efficient regions that we could choose, or is everything coming under the same cost?
No, that's a good question. For free tier, you are absolutely no charge at all. Only for, when it comes to region wise, you will be charged accordingly. Let's say like you have United States, your price will be much more higher comparing to Asia. So likewise, pricing will get differ based on the region you choose. So it's not that, in simple terms, I would like to say, when there is a project, right, you have all your data residing under US, you cannot store all your data in US data in other region. So there is a data compliance will occur as well. So just you want to ensure that you are storing your data, I mean storing the project data only in that respective region. So you understand, right? So it's not about the costing, it's about the data complaints that it actually serves. So we can even, there is a possibility that you can even choose the cross region as well. Even US data can even store in Asia as well, but as per the data complaints it has not been allowed. So we are not requested, or we should not think in terms of costing perspective. Anyways, for free tier usage, we are absolutely free to use this S3 bucket. So for free tier usage, you are entitled to use 5 GB. So totally you can store 5 GB of data. Does that answer my question?
Yeah, it did answer. Thank you.
Thanks a lot. Thank you. Right. So yeah, so I've just given the bucket name as well. So you don't want to worry about the other things. So you can just simply go on and create a bucket. Looks like there is an issue. All right. So what I'll do, all right. I'm just going to simply create my bucket. It necessarily speaking, bucket should ensure that bucket name is relying upon the policy. So there are like couple of checks will be taken care at the time of creating a bucket. So please ensure that you are creating the bucket as per the AWS management policy. So the bucket which we have created is absolutely, free of cost. So we don't call them as, file storage. So rather we should call them as object storage. Any files that you can have, you can just simply upload. Let me say, like, you can just simply add your files here. Maybe like I'll go here and just storing my all my data here. So all the data which is being stored here in S3 as an object, it is just to be served as a key value path. So it is just trying to upload the data. So there is no upfront cost to upload your data in S3 bucket. As I said, for free tier usage, let me go here. The box which I have mentioned here, till 5 GB of storage, you are entitled to store in any S3 bucket. Okay, even you can store in one region with 3 GB, and even you can store 2 GB, other 2 GB storage in another bucket as well. Even another bucket in another region. That would like to say. All right. So S3 is, very, very important. It's not only for storage, it is the main place where your input files will reside. Let's say, like, in terms of any project, you need to have some input as a data source. So you can keep all your data as a source in one place where we can refer that as S3. So simple storage service, it is treating as a good service. Without this service, there is no data engineering project can be hosted in cloud, guys. Okay, amazing thing. There is no alternative to S3, guys. So only S3. There are couple of services are there, like, Amazon Glacier is there, but Glacier is not something like, it provides 100% availability. You cannot, read the data very fastly. So S3 is the one where you can read the data fastly, and also 24/7 availability across multiple regions. So S3 is very important, guys. So keep a note on that. And then coming to the
So,
next
yeah.
one.
Sorry to
Yes.
interrupt, Rajesh. So it was really understood. So one thing, I have one question. So you
Yeah.
mentioned about S3. So I just have a, not understanding what is exactly object. Like, how do we
Okay.
store the object? Why do we call it the object storage? Do you,
Okay.
can you show?
Basically, that's correct. That's good question, Armagam. So while we say, like, in terms of files, we store it as an hierarchy, right? So all the files where we can store, maybe it can be an HDFS or Windows native file system, it can store as a file system in terms of, hierarchy wise. So all the files can be read in terms of hierarchy level. But when it comes to object, right? So in S3, why we call them as object is because objects can be treated as in the form of key and value. Let's say, like, the file name can be a key, and the value can be the contents which is present inside the file. So let's say if there is a file system, so if you want to treat it as a file system, right? So
Hmm.
there are like couple of things. There, the metadata will not be supported for any, other services. So it's absolutely necessary that S3 should treat it as an object, because the other services, right? Let's say I want to have it as an ETL tool like Glue, that only accepts an object to take the incoming data, not as a file ready-madely. So
Okay.
it will not accept it as a file. So that's
Oh,
the main reason why in AWS they refer and call them as object.
oh, cool. Thank you.
Cool.
And also, we just to give the audience overall context. So, data engineering, when we talk about, we store the data and then we process the data and then we just visualize the data. So, this is entire data engineering flow. So, we just see first part data storage. Just correct me if I'm
Exactly.
wrong.
That's true. So when it comes to technical wise, yes, data ingestion, data transformation, and data visualization or data reporting. There are three parts where we can segregate or have our project to be modularized, right? So
Yeah.
we are into data ingestion part now. This S3 will be worked out for that.
Sure. Any doubts so far, guys? You're able to understand everybody?
I have a question, that this is regarding how we store the data. When we mention in S3 we store it as object, and when we refer to as a key value pair, is it only for a retrieval that we are talking about? How is it different? How is it different from the normal HDFS storage and when we call it as an S3 object oriented storage? I'm not able to visualize.
Okay, that's what. So I will teach you, like, when it comes to glue particularly, because that is a good concept on understanding S3. Because S3 is just simple, guys. So as you rightly asked, why we call them as objectives, because it needs to be read in the format of key and value pair. Because any any tool in AWS that accepts the data as not as a file, it only accepts as objects. And one more thing, if you keep that as an object, your file storage, right, the storage which is occupied under one particular bucket will be very, very lesser. So in terms of reducing cost wise, it will benefit. That is absolutely important, right? That's why we always go to cloud as well. So there are four things. One is cost savings, and there is a flexibility involved. Like whenever you have any increase in your demand, or anything you wish, you can have the flexibility. And then there is scalability. When you want to increase or decrease your resources, right, so you can go ahead. And then there is a demand in, when it comes to data demand, you can even still refer this S3. So I will take you through that object concept when it comes to glue, guys. Okay, so this is what. So when it comes to data storage, right, object will be well preferred comparing to other files. Is that answer your question? Maybe I'll take you through the glue when it comes to that.
Sure. Yeah,
All right.
that should be okay.
Cool. Cool. Thank you. Right. So we have seen that how to create a bucket here. Yes. So here we have created a bucket, and also we have uploaded the file as well. So now we are going to the second service in the list, which is nothing but EMR. EMR is nothing but, simple, guys. It's Elastic Map Reduce. So it is a basically, it's Amazon managed Hadoop framework where it will be used for creating a cluster. Let's say you have a big data project that has a infrastructure developed, right? So that span across multiple clusters, that can be a test cluster or production cluster or QA cluster, that should have multiple servers involved. So likewise, when you want to run a Spark job, let's say, or when you want to run a Hive query, so what you need to do, basically you want to have a cluster ready made. So in AWS there is some specific tool, we call them as EMR, Elastic MapReduce. It is a till petabyte, not till petabyte, even beyond the petabyte, it can scale up resources. And even you can install necessary Apache softwares, like in the market, like Spark, Hive, Presto, even Scoop, HBase, etc. All the Apache softwares are included here. So EMR is the best place where you can create cluster, where EC2s are involved. Okay, I'll go through the EC2 in my next slide as well. So before jumping into EC2, I will be explaining you, like, EMR, how it can be created. So it's very simple to create a cluster, guys. As I said, there are, like, at the left side of the Explorer, we have a couple of good stuffs like understanding what is cluster, notebooks, and everything. Now, I have already created my cluster for my best practices. So if you see here, right? So basically, there are three nodes which are available in this test cluster, not test cluster, any cluster that you create under EMR. Okay. So now how I will say it is, the capacity will be three. One is a primary node, one is a core node, and one is a task node. Even if you see here, it has various EMR versions accordingly. So this is going to be the 6.x very latest here. Even there is a latest one beyond 6.15 as well. I think like 6.17 is a much latest one. I have chosen 6.15 because as per my requirement, I want specific applications to be installed, like basic things: Hadoop, Hive, Spark, and Scoop. So I have all these softwares installed automatically by EMR itself. So EMR creates the cluster and installs all the server. So if you see here, right? So I can go you through like instances. There are three different instances that are available. One is a primary, one is a core node, and one is a task node. So basically, when you want to run a big data job, it can be Hive or Spark or Scoop, as I said, right? You can just simply create EMR cluster in your console as well. So there are two ways to create EMR cluster. One is via this EMR console, and the second one is via using step functions as well. So step function is simply, it's just an orchestration tool. I will let you know, in my upcoming slides. So when it comes to three different nodes, one being the master node, as we know, like the topology in Hadoop, right? The master node and the slaves concept, like worker nodes and the name node and the data node concept. Similarly, here also there are like three divisions. Primary being the master node, and core node, it acts as the task node, where it keeps all the metadata and not the metadata information, all the files related information, or the files actually files, in terms of storing physically. And when it comes to task, it is a worker node, it is a slave node, where your job will be running in the task node accordingly. So the image that I have selected here, m5.x large, is the free tier version that I've chosen here. Even you can choose the other version also, but its charges are applicable here. So please make sure, guys, whenever you are spinning up your EMR cluster, make sure that you are selecting this m5.x large or m or t2.micro at least, because that will be coming under free tier usage. Okay, so now the moment I created, it gives you couple of, when it comes to Spark, it gives you Spark S3 server, and when it comes to resource management, it gives the Yarn timeline server and everything. So once you create your cluster, you will be given a physical IP. So here you will be having the physical IP. We call them as a virtual IP in AWS. So you can take that IP, you can even connect to the server via a PPK file or any kind of security mechanism. That's so simple, guys. Beautiful thing about EMR is whenever you want to have your cluster on, you can simply on. Let's say my project has a requirement to have only 4 days a week. I don't want to run it on weekends like Friday, Saturday, and Sunday. I can just simply switch off my cluster. So there is an option called auto termination. So if you see here, there is a termination, right? So you can have that settings as well to enable it, or you can even disable it as well. So at the time of cloning it, or at the time of creating a cluster, you will be able to see that auto termination facility. So as I said before, right, EMR 7.x is the latest version here. So you have like different versions available. Let's say like I'm just selecting this. So any version which has the necessary software will be listing out here. So it's our actual thing that you can select whatever let's say like I don't want anything other than Hadoop, Spark, and HBase. Yes, it's absolutely easy. All right, so you don't want to worry about anything at all, and you have the provision to select whatever the instance you can have. So I'll cover this instance type particularly when it comes to EC2. That's the next topic, guys. But please ensure that you don't select anything other than that m5.x.large or t2.micro. Okay, because it will be charged accordingly. I have selected because I have some requirements to for my for some of the projects that I'm working on critically, so I've just chosen this EC2 instance type. But it's up to us to select any of the instance that you can work on. All right, so when it comes to auto termination, as I said before, you can choose this option, right? So you can manually terminate cluster if you don't want to automatically terminate cluster. Let's say like when the cluster is very idle, after 1 hour, you can just simply have this enable option, and you can just, don't want to worry about anything. Automatically EMR shuts down your cluster. So as you know, right, cloud is something like, pay as you go or pay as when you use. Whenever you try to use the cluster or use the resources which is there in AWS, you just want to simply pay. Other than what you don't use it, you don't want to pay at all. That's a simple concept in any cloud that you take, not only AWS, in any Azure or GCP or whatever, right? Yes. So this is very easy, and easy to create cluster first of all, right? So any doubts in this, guys? So that's why I mentioned like no free usage. Please ensure that you are selecting the right EC2 instance that you are going to create in your cluster. Normally it takes only 5 to 6 minutes to create the cluster, guys.
So without EMR, there is no other way to use any kind of Hadoop in AWS.
We can do, we can
Okay.
create an EC2 instance manually. That's what
Okay.
EMR is nothing but it internally creates EC2 instances. If you
Okay.
look at this picture at the right side, right? So EMR just connects to different EC2
Hmm.
instances. So that EC2 instances, what you need to do is you need to manually install all the servers. Like as we know, right?
Okay.
In Hadoop there are
Understood.
two distributors, Cloudera
Yeah,
and
yeah.
Hadoop, right? Now
We
it's
can install.
united,
Correct.
right?
Understood. So if we
Likewise, you need
create
to do
a
manually.
EC2 manually, so should
Mhm.
we also need to, give the networking details, everything we need to
Yes,
configure it?
exactly. We need to do
Okay.
all the provisioning,
Hmm.
all the networking, security,
Everything
VPC, and
manually.
everything.
Okay. So
That's what.
nobody does that though in that case, right?
Nobody does it. Yes,
Okay.
it's
So
our
just to
core
give the context
responsibility
here.
to have it.
Okay, cool. Yeah, just to give the context to the audience, if somebody is not from data engineering background. So what is we are trying to do here is we are trying to create a cluster. What is cluster is nothing but it is bunch of systems joined and then it acts like one big unit, like one big unit. That's what it is. And EC2 is nothing but we can create a laptop in the cloud. That is EC2. That's what I understood. So because always I
Yes,
forgot that.
it, it
So
is a
is it
virtual
right,
server. Maybe we
Rajesh?
can call it. It is a virtual server. Yes,
Virtual server. Okay. Thanks
yes.
for
It is
correcting.
just
So
like a laptop.
laptop,
Your wording
but
is correct.
more
Yeah,
powerful.
more
Correct, right?
powerful. Yes.
Yeah, I guess. Okay, cool. So, anybody has any doubts so far, guys? Or okay, I think.
Can we move on?
Yeah, sure. We will have a doubt session at the end. Then in that case,
Sure,
so we
sure.
just saw two things. One is first S3, now EMR, two services we covered. So S3 is nothing but services, bunch of services. We just need to know what that service is, how to use that. Then you know S3. Am I right
Right.
also in this way, Rajesh?
That's true. That's true. Basically, it's just
Thank
a storage place where you keep all your incoming files, or after you do some data transformation, you simply want to store all your data, transform data in only one
you.
place called S3. That's so
Okay,
simple.
cool. Cool. Go ahead, please.
All right. Thanks, Arun. Right. So next in our list is EC2. So this being covered in EMR as well, but it's our responsibility to understand the fundamentals of what is EC2 here. Right. EC2 is very simple, guys. So it's like as our virtual server, it is our laptop or it is a machine that where you are going to create an instance in your machine, right? In cloud more particularly. So cloud offers you like couple of options to create an instance. There are like n number of instances that you can create. It's there is no restriction or there is no limitation, but yes, when it comes to free tier usage, you are entitled to use 750 hours per month only for the instance type called t2.micro. Anything you choose other than this t2.micro, it is absolutely chargeable, guys. I will also show you a couple of how instances are segregated. Maybe like I'll give you a quick background on I'll just show you the CSV once we download from the AWS management console. All right, so this EC2 is nothing but the server where our jobs are going to run. Simple. Where your Hadoop is going to install, where your Spark is needs to be there, Hive, HBase, Scoop, Flume, Sentry, all the necessary big data softwares. It's just a Linux server basically, guys, where you are all the application related softwares are going to install, and then you are going to play with that. All right. Now with this, we are going to go to EC2 console. Let me go through here. It's very simple, guys. Whatever the service that you are going to hit in AWS, just type the name. It will just give you all the necessary details. Simple. So just click on EC2. It will give you like couple of good things here. And I'm going to choose instances before going into instances. So these are some of the sample, practice instances where I have created for my own testing purpose. Before going into that, let me show you like instance types that I have promised to show you. So it's just keep loading it. Yes, there are like close to more than 761 instance types are available. If you don't want to explore it in this explorer or console, you can just simply download it. So you can just simply go here. You can able to see all these necessary details. So from this, AWS provides, it's a beautiful thing that before creating an EC2 instance, you want to simply ensure that what type of instance that you are going to create. It is our you know expected responsibility to go ahead and choose the particular instance type in respective available zones. So if you see here, there are like couple of columns are available where this gives you like instance families. So when it comes to A, it is accelerate computing family. When it comes to C, it is compute engine. compute in the sense, some applications or some jobs requires more computation power, which means it needs combination of higher RAM, higher storage, and higher processor. That's we call them as compute oriented, right? So such applications always prefer to go with C. And when it comes to T, it is storage perspective, guys. Storage in the sense, you require only minimal RAM, you require minimal processor, but you are going to store an abundant volume of data. Let's say like you are daily, your source is generating 1 terabytes of data, you can just simply go with this option. So A, C, T, accelerate, compute, and storage. And even there is one more thing called M is nothing but memory optimized. So you are more focused on memory. Let's say like Spark is moreover focused on, it's a computation tool where it eats more memory, right? Because it does jobs in RAM, physical. It's not, virtual. So memory optimized is the one where your jobs requires more amount of memory. So likewise, you can just simply go through here based on the instance type that you want. You can just simply take it up, whether it is going to be a large or micro or small, anything that you can decide. Now let me go through this console where I have like couple of instances ready already, right? I'm just going to simply create my instance here, which I have already created. So what I'm going to do, simple, I'm going to do two things. One is, already this instance have been created, I'm just going to start my instance, guys. If you want to start a fresh instance, you can still do. You can just simply click on launch instances, you can simply launch a new instance. At the time of launching an instance, you are entitled to select any instance type or any combination, or maybe Arumuga might have discussed, right, that the network or the security, that whatever you have, right, you want to choose accordingly. So let me show you here. So it is just trying to start it, right? So the moment it transits from stopping to running, which means that our server is ready. Okay, it is, remember that this is not a cluster having multiple server, it is a one virtual server. Okay, at a time we can run queries in this one virtual server. Well, let's say you want to explore some testing, you have to install Hadoop and Spark, you can just simply install here and you can just run it. And you can get the, for any testing purpose, let's say like you want to do some troubleshooting, you can just simply create the EC2 instance and you can just do accordingly. I'm just talking in terms of Spark, you may be having any other requirement or use case as well. All right, yes. So when it comes to here, right, EC2 instance, absolutely, networking and security is very very important. So when it comes to here, I have selected couple of things, like one particular VPC. You are about to create this VPC upfront when you are trying to create an EC2 instance. VPC is nothing but virtual private cloud. So it has like all the networking related concepts, like all the security groups. And security groups involve, like what basically it is an inbound and outbound, we call them out, like which server that you want to hit, or from which server you want to get the data, on all those necessary steps. So all these things, right, that you can see it in, at the time of creating your EC2 instance. Let's say I'm going through the security group which I have created. All right, so you can have, you can have a couple of inbound and outbound rules. Basically it's, it's just an HTTP request, guys. If you don't want to enable it, port number 80 or port number 40, you can just simply disable it accordingly. So this gives you a proper background on, how you want to select your EC2 instance accordingly. By default, there is a security group which is there in AWS. You can even select that security group also if you don't wish to create your own security group. So understand clearly, like whenever it comes to data sensitivity or anything confidential, let's say like a banking domain has some confidential data, they don't want to have all the, consumers to hit the API and get the data extracted. They simply create their necessary security group having all the necessary inbound and outbound rules. So now let me go through the back, instances, where I will show you like how to connect to the instances as well. Maybe like I'll just go to the, instance types. All right, let me go to the instances. All right, let me go here. So now we have started our instances. Let me go here, instances. There are one instance which we are running. I'm going to start this instance, guys. So how are I going to start? Simple, just click on connect. It will have like couple of connect options. The best and easy way is to use a putty. That's called them as EC2 Instance Connect. So inbuilt, AWS has the necessary putty and NSCP softwares that actually connects to that. So when I simply connect it, it just shows you a console. It is basically a putty, or an interface where you can connect to the Linux box, and you can play accordingly with the data, or any softwares that you can do. Even if you want to install a Python, you can just simply go ahead and just start exploring it. Even if you want to install Hadoop manually, you can just simply go here and you can just do it anything that you can. All right, so this is one of the virtual server we have just started. You can do anything as you wish. So remember that if you start instances, please ensure that you want to terminate or you want to stop the instance manually. There is no auto termination facility available as like EMR we have seen, right? So there is no auto termination. So please keep remember that only we are entitled to have 750 hours of T2.micro. You are not about, you don't have the option to select other than T2.micro, but yes, there are some options to even select other than T2.micro, but you will not be able to use the free tier usage. You will be charged accordingly. I will also show you, like, there is a beautiful interface we have in AWS called AWS billing. Okay, the billing concept is nothing but where it shows you upfront what is the bill that you are charged for a particular month. You can clearly able to see, like, what is the bill generated for this month, and what was the bill generated for the previous month, what are all the services that you have used, and what is the charge they have been levied. So that's very so simple, guys. So that is the reason why many corporates or companies, they are preferring AWS as one primary tool because of the beautiful interface that we have. All right, any doubts on EC2, guys? You can launch any number of EC2 instances as you wish. You can you can create like 5, 10, 15, anything you wish. But please do remember, you want to stop the instance manually. Any doubts, guys, in EC2? It is just simply you can just relate to a Linux box in your in your machine. We have just simply created a Linux box for performing all your playing with the data, or creating, or installing the necessary applications. No doubts, guys? Can we move on? Any doubts, Arumugam?
Sure. Just I'm able to understand. Thank you. Let's move
Great.
on.
Thank
I
you.
just summarized whatever we discussed in the chat so that you will be able to refer. So just for your reference, for the audience reference, I'm just putting what are the service we
Great,
are seeing. So cool, we can
great,
go.
great. Sure. Thank you so much, Arumugam. Yeah. Next in the list is AWS Lambda. Yes, absolutely very, very important service that any project without Lambda, they will not go ahead, because absolutely it is serverless. So when it comes to serverless, what it mean? You don't want to physically, create a server or virtually create any server, because AWS manages its own servers to run the application. When I say application, it just basically a function basically. So Lambda function we call them out. So it runs the basic code, or the code can be in any language, guys. You can even use Python or .NET or Java or anything. Even Golang is even supported. I will go through the uh, Lambda function how to create in AWS management console shortly. So basically, in free tier usage, you are about to have 1 million requests per month. It is nothing but how many requests that you are hitting in Lambda function. I will tell you, like, it's basically they will calculate on compute time. So the time, how much time it actually the code runs, it is the calculated criteria to have the price accordingly. So you don't want to worry about in when it comes to free tier usage. 1 million requests are absolutely free. All right, so in this slide, I have given a short picture here explaining, like, how best the Lambda can be used, because as a data engineer we may not be easily correlate with how Lambda can be used. But yes, I will explain you at the end of the session with a beautiful use case. But now, see, at the first, there is a code commit, right? So code commit is nothing but it comes under DevOps or code deployment service, criteria, where code commit is nothing but where it is as equivalent to a GitHub. So where we know that GitHub is a shared repository where you can have all your source code hosted in the cloud. Similarly, in AWS, we have a respective service called code commit. You can have all the necessary source code or configuration or any files that you can keep in code commit. In DevOps, in AWS, when it comes to services, there are 5 things. I'm not going to explain all these. I'm just giving you the name for our perspective, or to understand. Code commit, code build, code deploy, code pipeline, and code artifact. Okay, code commit, as we know. Okay, let's say in this scenario we have some files. Okay, in day number 2 or 3, we have some configuration files added for running our Python application to enable Spark job. The moment it have the configuration files updated or newly added, what we can do, we can design a lambda function here. I will show you how to create a lambda function shortly. Lambda function, you can create a lambda function to continuously check if there are any source of information reflected in your code commit shared repository. So your function will automatically detect your source as a repository to understand if there is anything that it is actually populated fresh or new. So the moment it gets new or it gets a signal, Lambda will then pushes, or even you can write a code to copy the repository data, the new data, whatever the data is fresh, right, to S3 bucket. We can have a bucket exclusively for storing all the configuration details, right? So simply Lambda runs without a server. When it say without server, AWS manage its own server. You don't want to pay, or you don't want to create any instances to run the Lambda function. Okay, let me go here. I will go Lambda. There is a tool. So if you just give a Lambda, the service name in this search box, it will take you through the respective service. I have couple of Lambda functions created for one of my artificial intelligence or other cloud related workshops. How you are going to create a function? Okay, let me take you through detect faces. This is one Python function, or a Lambda function which is written in Python. It's very simple and basic code, guys. Okay, so I have enabled the recognition is one AWS service which is used for artificial intelligence. Okay, now this is in the Python format. So Python is a programming language where we use to create this function. Now I'm just simply going to test it. All right, so it will give you the results. That's it. So where it actually runs is, we don't want to worry about. It runs in its own server. Wherever it has that respective server in cloud, AWS manages it. You just have your code in any Python language or Java or Golang. Maybe I'll just show you. Maybe at the time of creating a function, you can just simply see it. All right. So you have all the runtime supported here. As I said, .NET, Golang, Java, Node.js, Python, anything that you wish. So you can just simply create Python 3.12. You can just simply create it. Okay. I'm just giving you name test lambda function. I can just simply create a lambda function. So lambda is, as I shown here, this is not only the use case, guys. Okay. In any project that you can take, lambda works as a best serverless compute service to understand the changes which you are able to detect in any of the system. Let's say like S3 is, that's what I said right now. S3 is one beautiful place. And even if you want to connect to a glue, even lambda will actually work out. Okay, so I'm not going more deeply because lambda and S3 EC2 EMR is more and more, there are a lot more to cover, but I'm just giving you only the fundamentals on how it actually work, and then how this AWS service is being used in one use case. Okay, so lambda, as I said before, it's a serverless compute service used to integrate couple of AWS services based on the requirement that you actually use. Any doubts, guys, for this?
So
So
one
simply,
thing, so
it
you
creates
mentioned
function.
about glue, right? Sorry, somebody's asking a question.
No,
So,
I was talking actually. Yeah,
oh,
no, go
okay.
ahead.
Sorry, there's one question. So you mentioned about glue. So what is glue? I don't know what is glue.
There is a topic glue. It goes
Oh,
next. I'll teach you.
okay. Sure.
I'll go ahead. Sorry, Armugam.
Oh, no problem, because you said this is used in glue, so I don't know exactly what is glue. So, okay, thank you.
No worries. Next topic is the glue only. Yeah. Any questions on this lambda functions, guys?
Yeah. Rajesh, I have a question. So Lambda is basically a serverless architecture, right? How about the spinning and the cost involved with it, the number of nodes, or how does that take the number of nodes or anything? Should we give that as a parameter, or
Mhm.
AWS itself takes it as an optimized values?
That's
And
true. The second thing which I've highlighted, right? Everything is managed by AWS. You only want to worry about how you are going to write our Python code. That's it. As per the requirement. Let's say you want to connect to S3. You want to write you want to select the respective S3 client, or you want to connect to a glue, you want to you want to enable the glue kind, whatever the code that you have written, that Python or Java or .NET code will be running in couple of servers at the background, but we are not entitled to see that upfront because it is completely managed by AWS. So when it comes to pricing or the usage, whatever you have asked, right? For free tier usage, it is 1 million requests per month. Beyond it goes to 1 million, they are charging like $0.5 per TB. Per TB in the sense like how much compute time it actually. Let's say you are running a Python, okay? You are running a Lambda, okay? It actually runs that maybe you have some 20 lambdas to trigger in a day. So that actual compute execute time when it comes to per day, maybe 20 minutes, let's say 20 minutes, that 20 minutes you will be calculated for a month, and then the number of hours it actually taken, right? That will be charged accordingly. So it also differs basically from region to region, guys, because in North Virginia, the lambda, because the thing is, right, AWS, as I said, the server that actually you don't have any um, um, authority to select the server, because what AWS will do, they will take any server which is very very idle, that server which can be in any of the data center. It can be a North Virginia or it can be a Asia Pacific also. So the charge that they are living is very very common. It is not as per the region that we are deciding, because only when it comes to storage we want to worry about choosing a different region because of the pricing concept. When it comes to lambda, you don't want to worry, you just want to only write the Python as per the requirement, because you want to connect to S3 or glue or whatever service, as I said, right? That's it. The total compute time is absolutely necessary to calculate the pricing. That's it. Does that answer
Okay.
your question?
Yeah, partly. And I have a follow-up question to this. So,
Hmm.
how about the server turning on and off? Like, who manages it? Is that also managed by AWS, or should we manage that?
Which server you're talking about? Is it EC2 or
Okay.
IMAR?
No, when we use Lambda, it
Uh-huh.
is serverless.
No worries.
So,
Yes, no worries. No worries. AWS, what it will do, it is just like a queue, guys. So it whenever any system which is operational or which is in on condition, it just simply goes and then execute your serverless, Python code. Because it actually checks for the server which is already available. Servers which are not available, it doesn't care at all. That's what the concept is. So you don't want to worry about whether it is available or not, because it is taken care by AWS itself. That's a good and right question, guys. So
yeah,
automatically
you're right.
AWS takes care. Yeah, you don't want to
Okay.
deep dive into whether you want to on or off, because it is serverless, right? We don't want to worry about that part.
Okay, all right. And at times the job, there will be bottlenecks or something, right? And the job would
Hmm.
just keep running.
Hmm.
Until we figure out, like, from L3 support or something, there would be a concern raised, right? Telling the job is
Yes.
running for more than so and so hours. So how to deal with that in such scenarios? Is that also taken care, or should we go and take care of it?
Yes, good question. So we have some certain threshold limit where we know that this lambda function will not take beyond 2 minutes. We can set it as threshold. So beyond it goes, we can just simply enable a notification. We don't have a text to be populated. What we can do simply, there is a topic called SNS, simple notification service in AWS. The moment it reaches the threshold, it just want to enable or trigger an event to call the SNS API. So that SNS API, what it will do, it will just gives us an alert whether I and as an SMS or email or any HTTP request. So based on that, as you rightly asked, right, any L3 support or any engineers, right, they will periodically check like why this lambda function is taking so much of time. There may be a chance that the resource constraint. So at times when AWS is meeting the in terms of demand, it even goes beyond the expected time. That's the right question. But 99.9% the chances are very less, because AWS manages it only, it goes to server which is very very available. So there is no chance of having this lambda function go beyond the expected time. But still, yes, we
Okay.
do have options to trigger the notification, as I said, via SNS. Yes. Yeah.
And how about a code issue? Like, because of the code, probably like,
Mm.
the code could have been like, hung, and it would still utilize the servers, right? Even in those cases, we will go and kill the job. So
No, when it
until we are not, it will keep
go
running,
ahead.
right?
That's true, but again, like we want to completely test our code. That's what I did here. So the moment you write the code here, right, we want to create an event simply. So that the event is nothing but every time when the lambda function triggers, you want to call the event. That because why this event comes is, as I said before, right, event is nothing but it just transits this lambda function's output to some other AWS. It just triggers the another API. Basically, it is not only like SNS. Even it can call the S3 API to store the data from one source to another target location as well. So as you asked, you should able to, or we should able to test the Python function whatever we usually write. All right, and then we want to deploy the function accordingly. That's what, it's very simple. Without testing it, right, even you cannot be able to deploy the function, guys. So we want to test, we want to create an event first and then test it, and then only you are able to deploy it. Maybe I'll just show you as I showed, right? So maybe if I here, so before deploying it, right, I just simply test that function. So I just, your deploy function will not be coming here. All right, so test event, I'm just going to simply test it, and then only I can able to deploy it. Okay, since the regions is not enabled, that I am not able to deploy it. Without doing a test of your application, you don't have the option to deploy it accordingly. Okay,
All right. Okay.
right. Okay, thank you. Any other
Yes.
questions, guys? Thank you, no
Mm.
problem. Yeah.
Yeah, I
That's
have
what
one query.
Yes.
Yeah, like Lambda have a limit, right? For example, sorry, like for execution time, like have 15 minutes threshold. Like
Mhm.
in case like my usage, like if it's exceeding 15 minutes, what will happen? Like
It will still keep running, but the thing is you will be alerted that it is going beyond the threshold limit. That's what, as a notification to the as an engineer, right, we may need to know that why this function is taking more amount of time than they expected. There are possibilities that it can take higher time, but the moment we see the expected time is going beyond, we want to slightly improve the function accordingly. But the thing is, right, the lambda function is not going to, we don't want to write a hi-fi or complex function here. Basically this lambda is what about is nothing but it connects to different AWS APIs to have our work easy. Let's say you want to connect
okay,
to an S3 API, you just simply write the client. Maybe, yeah, I just go here, right, I'll just show you
okay,
this
I got it.
function. Yeah.
I got it. Like what
Mhm.
I'm asking is like a maximum amount of time for
Mm.
Lambda function run. That is like
There is no maximum
I
time,
think.
you have n number of time. There is no maximum time, that's what.
Okay, recently I did one course. Like in that course, like they mentioned about Lambda function. Like its maximum time is 15 minutes.
No, it
So
depends upon the usage. That's what, in free tier there is a limit, but when it comes to resource wise, like you are going to a a premium editions, right, there is a limit. It's not 15 minutes, we can go with even 30 minutes as well. The double of 15 minutes we
okay,
can go.
okay,
When it comes to free tier usage, you don't have the necessary options because it will not go to complete all the AWS services. It only restricts to only minimum services that actually it uses. So that's why they have not given as any threshold limit here. But when it comes to premium, you have that limit accordingly, so that, like, it's not 15, it is 30 minutes basically. But still, even it goes beyond 30 minutes, it will run the job as a chain job.
okay, okay.
All right, cool.
Yeah,
Any other
okay.
question, guys? Somebody was
Yeah.
speaking.
If it goes beyond the threshold, is it
Hmm.
possible to terminate this event manually?
No, it is not possible, guys. Why? Because it is not actually maintained by us, because this has been serverless, as I said, right, it is being completely managed by AWS. Only the thing is we can only kill the step. Okay, not the function. So there is an option. You cannot, you will not come to know like how much time it is actually taking. Yes, we can do. There are like other, we have like Airflow. People might know, right? Apache Airflow for managed workflows. The Airflow, it's a Python based. So you will come to know whether this Lambda function is how much time it is actually taking. In that workflow, you have the option to kill it. Let's say like you have to run only for 10 minutes as expected, it goes beyond 10 minutes, you just simply kill it accordingly. So that will be taken care by the administrators or L3 support engineers, but not the function manually from the Lambda service. Here you cannot, you cannot kill the function manually. Here you can only terminate when it comes to a step or a state when it comes to workflow. Does that answer your question?
Yeah, but I'm a little bit confused. What do you mean by terminate or kill the step function here?
Okay, terminate in the sense, okay, let's say this Lambda is being as one of the step in our workflow. Let's say first we have an S3 bucket to have the data ingested from one of the source. Okay, and then after ingesting data, there is second thing in our workflow. Basically workflow is nothing but it is a series of steps, it runs one after the other. Consider the second step being this, right? Lambda function to understand if there is a data change occurred as like CDC in S3 bucket. Let's say your bucket, okay, I'll tell you one scenario. If the bucket is not accessible, okay, there are two options. One, if the region is not available, when I say not available, it is down. Let's say if the region is down, if the AZs are down, yes, there is an option to have your data replicated in other cross region as well, but provided if there is a worst situation, if there is a downtime occurred, your Lambda is not expected to get the necessary input or expected input from the S3 client. So what it will do, it will keep running, right? At the time, what you can observe manually is in the workflow, you can simply kill it manually. So in workflow, when I say I will go there is a service called step functions. I think after two more services I will show that accordingly. Step function, and basically it is a series of workflows. Okay, in that you have the provision to kill it manually, but when it comes to terminating this function manually here in this Lambda service in AWS management console, you don't have that option. That's what I'm saying.
Yeah, I understood your point. But the concern here is
Mhm.
killing the step is the front end view. For example, when we are going into the airflow, we have a series of steps, parallel steps. Okay.
Right.
When I kill a step in the airflow,
Mhm.
that impact will have only in the airflow. And you're
Correct.
saying at the back end, the Lambda function is still running. Okay. So in that case also, I'm getting charged from the AWS, right?
Yes. Yes. That's
So
correct.
the question is, I want to avoid this charge because I know in some time between
Mhm.
of my some program, I got a point that I had a mistake in my Lambda function, which is I couldn't able to suspect before. So
Mm.
I want to avoid this charge. So killing this step function will be in the front end, but I want to terminate this Lambda function. So in this case, the only choice, what I understood is I have to reach out the AWS support. Is it?
That is one option, and also there is a programmatically what you can do. You can set the threshold, right? As I said before, whenever any threshold limit exceeds, you can even auto terminate accordingly. That is also a possibility is there. You
Okay,
got it?
auto
So that
termination. Okay,
yeah,
okay.
yeah, auto terminate is possible. Yes, but one thing we want to be very clear is auto terminate will not be enabled for all the AWS API services. Only for respective services. Maybe I'll just tell you, maybe only for few of the clients like S3, Glue, Athena, only it supports. Other services we don't have the liberty to have the auto terminate facility. So in this case, right, maybe I'll just showing you here, we are enabling this client called recognition. Likewise, you will connect to an S3 client, you will connect to a Glue client, you will connect to a Athena client. Other than the client that you enable in your Python function, you don't have that option to have the auto termination, because it's simple, guys. It's only for the business perspective. So they understand clearly that they want, somewhere they want to give a free usage, and then it should be chargeable in some ways. So that's what, it's not only AWS, any cloud provider that you go, they will give you a free usage, and beyond that there is some, a limitation will be actually happens in some worst case scenarios, where you can avoid it using these options like auto termination. But it's not for complete all the services. Maybe I'll tell you, like, in one more session, maybe, like, because it requires a complete coding actually, because this session is only focused on having what is the service and what it does and the use case. Maybe I'll explain you, detail about that. But there is a provision to auto terminate, but only for few of the AWS services.
Okay.
Okay, I think we'll move on to other services. So we'll take the questions
Cool.
later.
Sure. Thank you. Right. Thanks for questions, guys. I hope that this session is very, very interactive. Thanks for asking a couple of questions so that I'll also learn accordingly, along with you. Thank you. All right. So the most awaited one, as Arumam asked, Glue. So Glue is, it is one of the fantastic tool, or, the service or API which is available in AWS, because basically, it is a it is something we call them as an ETL tool. It has all three modules, like it has an extract, it can transform, it can load as well. Okay. So when it comes to extract, as you see in this picture, right, you can connect to any connectors. Let's say your connectors, even they call it as data stores. You can connect to an S3 to have the data ready, or you can plug in. Connecting in the sense, you can just simply connecting to the client, S3 client, and take the data. And then this crawler, right, at the middle of it, crawler is nothing but, we call them as Glue data crawler. So this crawler, what it will do, it infers the schema from the data stores, where it actually pulls. Let's say we are connecting to an Oracle client. Okay, just for an example, via JDBC client. Let's say we have a database with couple of tables. So this crawler, what it infers, it takes all the schema details, I mean the metadata, and it keeps storing here as a classifier. Okay, there are like two classifiers available. One is the custom classifier and built-in classifier associated with the data types. So in any connector that you have, right, always data types is very important because of the data available in that respective format, because data should be there in that respective to have the data enrichment. So crawler will infer the schema, and then it writes the metadata accordingly to create the data catalog in some load operation. So in this case, data catalog is nothing but you can still have your target as your S3, or you can still have your Athena as one of the target, where your, you know source, where you have pulled, right, you are doing some operation, and then you are just doing the loading. You're just loading the data in some catalog. When it comes to data catalog, you can have any database in AWS, or any storage, I mean the file storage that we call that S3, or any other, Glacier or any other APIs as well. Maybe I'll show you like programmatically. It is not only like, it only connects to a JDBC, guys. Even you can connect to any of the inbuilt Amazon providing services as well. That's what it has mentioned, like S3, RDS, Redshift, anything that you go. Okay. Maybe I'll just show you here. Maybe you can understand better. There is a visualization tool, even you can write the code as well. All right. So I would like to go to Glue before that, showing into Athena. Right. Yes. So at the left side of the Explorer, we have like couple of things. So as I said before, right, crawlers. So you can create your crawler accordingly. So this crawler is nothing but you want to set your data source, whether it connects with which connector. It can be a JDBC, or it can be a file storage, or any API, or anything. It's a kind of web server or anything that you can take. There are like more than 70 plus, data sources available. Maybe like I'll show you that first. All right. So I'm just simply going to the visual ETL. All right. So I don't want this. So it is for the practical purpose. Okay. You have these options over here. As I said, source is nothing but the place where you extract your data. So the options here, right? You have like a couple of options. You can even read the data, maybe a JSON file or CSV file from an S3 location. You can still get it. Or even if it is a third party, let's say we have a MySQL client. Okay. Let's just start integrating here. All right. Even if you go, even if you scroll through, right, you have like couple of, sources available. As I said, right, there are like more than, 70 plus sources available. Now here I've just simply chosen MySQL. Now the moment you choose this source, you want to do some transformation, right? So the respect to source whatever you have chosen, the respect to transform whatever you can do, it will just simply populate in this explorer. All right. So whatever the options you have, right, you can just simply take it through. Let's say you want to select some fields, right? You can just simply enable it. And then, so what we are doing, we are just going to connect to a MySQL client via JDBC, and then we are going to select some fields, and then we are going to select some target. So what I'm going to do, I'm just going to simply populate in S3, let's say. So even I can go to data catalog, maybe like, let's be very simple. I'm just going to here as my target as S3. Let me minimize it. All right. So this being your extract, this being your transform, this being your target or load, where you want to, after you perform your transformation, you are going to store somewhere, right? You can even have it as S3, or even you can have it as RDS, Redshift, Aurora, or anything, even as DynamoDB also can act as a target location where you can store the data as well. So this thing, even you can customize accordingly, guys. Okay. So you can even, you want to do like multiple transform. Let's say I want to, I want to do some drop fields. I can just simply use this. Okay. I want to have this right in my after data source. So what should I do? I can just simply go here. All right. Just select it. I can just simply just select this. All right. All right, I can just simply here. So once I select this extract, the MySQL, you have like a couple of options as I shown, right? You can connect to it any source that you can do. You are just doing two operations in your transform logic, selecting fields and then dropping fields, and then finally you are going to store it in your S3 bucket. Now, this is a visual part. How are you going to manipulate or interpolate to in a script? You don't want to write anything. Even if you want it, you can just simply write it, guys. How? You can just go to script. It just simply converts everything as a script. I can just simply copy. That's it. So in return, the moment you start pulling your extract and transform and then load, right, you can have all the scripts ready in Scala code. Absolutely. The moment you complete, sharing here. All right. So if you want to just download it, you can simply download, or if you want to still, you want to add any other source, or even, you want to do some any customization, you can just simply edit this as well. All right. So this script, we have nothing we have done. We have just simply added all these E, T, and L. The script automatically populates it. Okay. So there are, like as I said, there are a couple of sources available, couple of transform, couple of target. So this being is, very powerful tool when it comes to, I would say like one best use case, when it comes to data cleaning. Okay. Data cleaning is very very important when it comes to, handling huge amount of data, because the data which you give to a Spark job, that needs to be very very cleansed, because you don't want to have all your bad data to give it as an input to your Spark job. So for that, right, you can do all your cleansing, data cleansing transformations in this glue service itself. You don't see for this, right, you don't want to spin up an EMR, you don't want to spin up an EC2 instance, because it is a serverless. As I said, for Lambda, AWS manages its own infrastructure to have this enable, to have this triggered at the backend, to get all the necessary data ready in your target. So simple is, you don't want to do anything. But yes, when it comes to here, you have, as per your free tier usage, you have only 1 million objects per storage is possible in your free tier usage. Beyond it goes, okay, the load part, that whatever you are actually trying to load either in S3 or any other database, right, that's, we call them as, storage, right? So extract or transform, right, you don't want to pay anything. So keep it in mind. For extract or transform, you don't want to pay anything, as like our Lambda function runs in serverless, right? You don't want to pay anything. Only the load part, where it actually loads it, right, that's what you are going to pay. That again comes under the topic of S3 or any other database. See, always, right, this AWS is giving free usage. It gives you a combination of free usage as well as some premium, some services where you will be charged. Okay, that's what the business is all about. if a person is always giving a free usage everywhere, right, people will never go to express or premium editions at all. But again, it depends on requirement, use case, all these things are referred. All right. Yes. Any questions on this, guys, this tool?
Yeah, what is the data catalog source you mentioned? Yeah, here you see the very first
Yes,
one, right? The view data catalog. It stores data itself or just the metadata alone?
it has all the data catalog in the sense it keeps all the only the metadata only, because it crawls it right from one particular data source, maybe a JDBC client, right? It keeps all the data. I mean, when it comes to data, it is a metadata. Glue data catalog is nothing but it will have only the metadata information. So obviously, when you want to store the data, you want to either choose S3 or any database. That's a good question, guys.
Okay,
Data catalog is basically it's only for writing the metadata. To store your metadata, or even you can have the metadata updated whenever your source keeps on changing, or even you whenever you add some logic in transform layer, right? In this transform, you can still have this data catalog updated.
yeah, thank you.
Yes. All right, any other questions? Armugam, any questions from your side, or can we move on?
Sure. We can move
Raj,
on. Rajesh. Sure.
Yes, somebody was asking. Yeah.
Rajesh, I understand like this Glue is for completely for serverless data processing. So so is there any common code based engines which is used for performing any data engineering related task in this Glue?
No, it
Like
is
I
not
have seen
supposed to be. Uh-huh.
I have
Yeah, go
seen
ahead.
that your screen. I have seen one is Kafka. How about
Yes.
Apache Spark, something like that? Is that possible?
We can do it possibly. Yes, what we need to do, but we cannot run it in serverless. So what we can do, yes, we can have that as one of the source. Let's say you connect to one Spark server. Let's say, like, you are connecting as a. So let me understand the question, whether you are asking about the transform where your Spark needs to be there, or as a source.
My question is like, what are the common code-based engines?
Okay, as like Kafka, right? Kafka and Spark.
Yeah.
Yes, we have the provision to have our Spark engine as well. Even what we can do for that, right, you will not be able to select it here in either of source or transform, not on the target. Even we don't have the option. What we can do, we can have this script enabled here. We can write our script to have the Spark base code here, so that we can run our ETL job accordingly. So here, if you see here, right, automatically this it is importing the Spark context. So basically, right, Spark, in terms of PySpark or Scala Spark, it supports. It is our responsibility to write it. So there is no common code is actually being present in Glue. Actually, only the thing is, we want to customize it accordingly whenever as per the requirement, guys. It just gives you a kind of source where you can pull, we can transform, and we can just load it, or target location where you can load the data. But when it comes to code, it is our responsibility to write it
Okay, perfect.
like this.
Yeah,
Cool.
I got it. Yeah,
You got it.
let's move into.
Excellent.
Yeah, sure.
Thank you.
Yeah, just to let you know that we are running out of time. We already crossed the time, so let's just
Yes.
go through the service titles and then what is the use case. Let's skip the
All right.
practicals for this. We'll cover in the
Sure.
next session or upcoming session. Just we'll give the
Definitely.
overview and then we'll close the session.
Definitely, Armugam. Thank you.
Thank you.
So next in our list is Athena. Athena is simple, like, many people will come to know like what is Hive in our data engineering, right? It's just a basic data warehousing tool where whenever you have some data in S3 as a, storage place, any data, it can be a, semi or structured or unstructured, you can simply query the data using a SQL code. So you just want to create some tables, and you can just simply query the data using SQL native queries, the data which will be residing under S3. Okay, so simply I will show you. I'm not going to run any queries. I will just show you the service itself. So if you want to create a table, simple. Go here, just go and just you have like couple of options. You can create table via S3 bucket, or you can create an SQL command like create table, or you can clone it from some other table like create table as select. So here is a place where you can write your SQL query. The data will be residing only one place called S3. So that is very important. So Athena is very, very, it is a very data warehousing tool, we call them out, but it's completely used for analytic purpose. Say, let's say you have some data and you just want to query the data very, very fastly. You don't want to go to Redshift because Redshift is quite costly when it comes to pricing. What you do, prefer Athena, just query the data which is residing under S3, just simply get the results. That's it. Athena, other than writing SQL query, it not involves anything. Okay. So free tier, it expects only you can query only 5 GB of S3 storage you can query. Beyond it goes, you want to pay. So free tier, it accepts only within 5 GB of S3 storage. When it goes beyond, yes, you're still able to query the data, but it's still chargeable. That's the thing. Then move on to step function. Step function is very, very important when it comes to, design your workflow. Let's say we have all the, couple of services, right? Like being it Glue, EMR, EC2, S3. How are we going to create it as a workflow? Let's say you want to first step, you want to have some data populated, ingested in S3, and then you want to trigger a Lambda function. And then based on the Lambda's output, you are going to extract the data from a source called, using a Glue API. And then after you trigger one more Lambda, and then you connect to a database. Likewise, you can simply, just create some couple of state machines in step function. So I will just simply show you. I'm not going to create any state machine here. I will just simply show you when it comes to create state machine, you have this option. Let's say if I want to simply create an EMR cluster, guys, what we will be doing is you have some already inbuilt thing. Let's say you are going to manage an EMR job. I'm just selecting this. I'm just giving an option called next. Here, it has series of steps starting from start to end. First, it creates it, runs the step, runs the first step is nothing but you want to configure whether it can be a Spark job or Scoop job or any job that you want to do. And then after the output or the status of the first job, it goes to second. Likewise, you can terminate the cluster. So this is one option. So there are like n number of options that you can do. Let's say like if you want to create the data up to date, you have all these options. So it gives you in the form of workflows. Okay, it connects with one API to another API. So it is up to us to customize our step function. So if I want to run only EMR, right? So that's what I showed you right here. So you can just simply create and manage an EMR job. Or if you want to have, after spinning up the EMR cluster, you want to have all the data populated in S3. You simply have, all these, at the after running the second step, have the S3 step enabled here. That's it, simple. So this workflow is very, very easy to design. It is also a serverless. You don't want to pay anything as you go upfront. AWS completely it manages accordingly. But the thing is, when it comes to free tier, it has only 4,000 state transitions. When I say state transitions, this is one transition. This from this to here, from here this to here, and it refers to one. From this to here, one. So likewise, in free tier, only 4,000 state transitions are allowed. Beyond that, it is priced. Okay, I will be sharing the details accordingly. What is the price? Because it varies from server to server. Here, then comes the Redshift. It is as equivalent to Athena, guys, because Redshift is somewhere like, it is more powerful because it is also going to query the data which is underlying in S3, but it queries only the structured or semi-structured. It's not, we cannot query the data or any unstructured data. Okay, but when it comes to Redshift concept, it creates its own cluster. We call them as spectrum. Okay, spectrum is nothing but cluster. It creates its own cluster and then runs the job accordingly. Basically, it just speeds our queries. It just we know that, right? Data is getting distributed. You simply go and hit the server in a particular job using your SQL. It just simply goes and get the result, but not in this case of Redshift. Redshift clearly able to create necessary spectrum, then hit your query and get the result very fastly. That's what many people, when people want to connect to any BI API, like, when it comes to Amazon QuickSight is one beautiful tool for reporting. They use only Redshift as their primary AWS service, because when it comes to Athena, yes, there is some limitation. It accepts only low cost queries, But when it comes to complex queries, always prefer to go for Redshift. Okay, you will get 3 times better performance comparing to Athena or Aurora or RDS. Okay, I would prefer mostly to Redshift because it. But the thing is, right, as like the performance gain, you're also being charged accordingly. Okay, so please be clear on having estimated all your queries accordingly and then go for Redshift. Yeah. All right. Then comes the one more topic called SQS, simple queue service. This is nothing but it just creates a queue and then sends a message from one service to another service. Okay, when I say one service to another service, let's say like from S3 bucket to you want to have one message populated as like test message to one more S3 bucket, or even you can just have the have a message to populate to a glue or to trigger a lambda function. Yes, you can do. So in order to communicate across multiple services which are there in AWS, you can simply use SQS. In other hand, there is something called SNS that I already told. It is for notification to enabling alerts, just to understand that if there is a threshold or if there is a job failure or if there is anything that goes beyond the expectation, you just go to simply SNS. SQS, simple. Create a queue, send a message from one service to another. I will tell you in while explaining the use case. Last, 10th service, DMS, database migration service. This is nothing but as like many people are there nowadays in IT or in engineering projects, right? In even in data engineering, they are just moving all the on-prem data centers to a cloud data warehousing or any database that you call, right? That preferably how you can do with very minimum effort. You don't want to have any support at all. See, we may able to get confusion like when it comes to schema or data types or anything, like when it comes to connection or connectivity or configurations. You don't want to worry anything about it. AWS data migrating service, it simply takes care of anything. All right, it supports 20 plus databases, but the thing is you want to connect either an RDBMS or any NoSQL database. So far it connects with HBase or MongoDB, two of the supporting NoSQL database it can connect. It can just simply converts all, I mean, it just migrates all the data which is there in your on-prem cluster to database. This you can even choose your database in your cloud. You can even choose, that's what it comes to Redshift or RDS or anything like DynamoDB. Any database you can choose, that is up to us. So you want to choose based on the pricing that you go. So whichever you have the requirement, let's say like you have a simple query, you go to Athena. If you have a complex, you go to either Redshift or DynamoDB. Likewise, okay. DynamoDB is most preferred to have anything you have any NoSQL database to get migrated. All right, right. So last but not least, we have one simple data engineering use case that I want like to explain. It's not a big thing, guys. I would like to tell you like there are like couple of re-engineering projects which are happening, right? So I will go from left to right. At left, there are a couple of sources available. Let's say like it can be any system. It can be a database or it can be a server, web server or anything. Okay, so here we have two different source connecting to an ELT system where it pulls the data. Maybe as I said, right, it may be connect to a database or it can connect to a file system. Maybe, who knows, it can even connect to an HDFS also. Okay, so this ELT system, again, it just populates all the data. We have two concepts, right? One is the historical data, or even you can incrementally ingest the data daily. Like we call them as change data capture. Every day you take the updated or refreshed data, we call that as CDC. You pull the data and put it into your stage bucket. So here at the starting, we have an S3 stage bucket, right, where it holds the raw data. Let's assume your incoming source file is a CSV. Okay, but my Spark runs. Okay, I'm going to trigger an EMR cluster that actually need to have the file input file as a Parquet. So what you need to do, as per this use case, you want to convert from CSV to Parquet. So what I'm going to do, the moment you have the file as CSV in your stage bucket, you are going to check via Lambda function. Okay, this Lambda function, what it will do, it has a necessary code. It is up to us to write our Python code. There is no inbuilt code available. Python code, it's not Python code, guys. It's even you can write it in Golang or .NET or Java, in whichever the preferred language that you prefer. You customize whatever the expected code, source code. Simple. You want to check whether it is CSV and do some validations, whether it has a comma separated, whether it has all the data, whether it has any bad characters or bad data or anything that you do. Who will do? Lambda. Lambda at the end, after completing it, as I said, right, it triggers an event. So basically you test it and you create an event, right? As I shown you practically, right? You want to create an event basically. That event, what it is going to do after detecting and validating everything, it just connects to a API called SQS here. So what it is going to do, it connects to SQS and tells the SQS that you want to send some message to another client called Glue. So at the top, you are able to see some client called Glue. This Glue, what it is going to do, it is just simply gets the data from S3 basically, right? So here extract is nothing but it's not the database, guys. It's S3, right? So it takes the data from S3 and then it just simply converts from CSV to Parquet. It won't simply convert. There is no inbuilt provision to convert it, guys. It is our responsibility or our thing to write the necessary code either in Python or Scala. Only two things that is actually preferred while writing in Glue script, transform script. So the moment you write it, you convert everything to Parquet, and then it goes back to the stage itself, the bucket. So let's say like we have two different buckets or two different folders. One for specifically to hold the raw data, that is nothing but it is keeping CSV, and then second bucket it is for you know let's say second folder, let's say it's, let's not talk about another bucket, let's keep it in the same bucket with different folder called processed. Raw contains CSV, processed contains Parquet. After you have the Parquet, again this S3, right, you can just have enable your SQS to trigger an event, trigger a message to tell that Parquet to be processed. See, this Parquet to be processed is nothing but just a message, guys. Okay, it's not something like an API or anything else. I'm just telling that from S3 to Lambda to confirm that you are going to check whether the Parquet file is valid or not. Okay, now what it will do, the moment you get the necessary alert or a message from SQS, this Parquet, I mean this Lambda function again, what it is going to do, it's just going to check whether Parquet file is has necessary configurations or necessary file format related stuffs. Some cases, right, it may be a zipped format also. In some cases it may be not a valid Parquet file, so we cannot take all those necessary unwanted data which is going into your EMR cluster, right? This Lambda, again you are going to write our function. Okay, Lambda function, any language, any preferred native language, you are going to write a function to understand Parquet file is perfect or not. Okay, and then the moment you complete, you are not going to again send the SQS or notification, you are just simply going to write it. The Lambda function simply have an have a provision to write the data to a S3 bucket. Okay, it connects to S3 a source, I mean the processed folder where we are having the Parquet file, and then it just simply move to another bucket called target. Okay, we don't want to confuse, guys. Stage will have two folders, raw holds CSV, processed will have Parquet file which is coming from Glue ETL tool. And then after doing all the necessary validation and all the checksums and everything, you are going to store in some target bucket. That target bucket will only have or will only hold the valid Parquet files. So which means data cleanse have been happened, data validation have been happened. Now you are good to use this Parquet files to your next step. Now this target bucket is used to, and then you know to use as a, one of the input data source to have your EMR. See, when I have this this symbol moving from this target bucket to EMR, it is not a step actually. The moment it have is data, you want to have one more thing here to have your step function. As I said, right, practically I was showing you in console, right? You need to have some lambdas triggered over here to understand that EMR, say, let's say, okay, going back to here, right? So step function, you have some provisions to have a lambda invoke. Okay, so you want to invoke your lambda here likewise. Okay, so this lambda, what it will do, it checks whether the target bucket has holding all the good data, and then the moment it has it, the next step is simple. Whatever we have seen here, right, create a serverless. You can just simply type like EMR, you can just create a cluster, simple. I can just add it here. That's it, guys. Very simple. sorry, Lambda invoke, and then this gets passed and then create the cluster. That's it. So this EMR, how we are going to invoke it? Via step function. Step function, the moment EMR creates it, EMR where it will actually take the Parquet data to run our Spark job, it takes from the S3 bucket. So EMR, once it gets completed, maybe the moment you have the necessary auto termination configuration enabled, the moment, maybe, who knows, Spark can complete in 20 minutes also, based on the complexity or the data whichever you have. The moment it completes, it just shut down your cluster and your data will get ready in your S3 bucket. It's not S3 bucket. You can have your target to have your S3 as a file, or you can keep your data in either in your database as well. You can even store your data as like target, in DynamoDB or Redshift or anything. Ultimately, when I say Redshift, again, the data is going to be underlying in S3 only. Okay. So this is one simple data engineering use case where you can completely use all the best and most frequent, AWS services here. After you have all your data in either S3 or any database, there is some tool called Amazon QuickSight. Okay. QuickSight is something, it's very, very latest, guys. It is for reporting, where you can, integrate your QuickSight API to an S3 bucket, or you can even connect to your Redshift or DynamoDB as well to visualize all your data. I'm not included it. Maybe I'm just giving you a suggestion to have QuickSight as well. But again, QuickSight is not coming as a free tier. You want to always, price chargeable accordingly based on the, uh, the the instance that you are actually selecting it. Based on the version that you choose, the template that it has, you will be charged accordingly. So likewise, right, you can have the necessary data engineering use case can be available. This is very simple, guys. Okay. There are like complex use cases are there, like, having SNS integrated to send some alerts, as somebody asked, right? How do you ensure that something is broken? Who knows, Lambda can fail. Who knows, Glue transform script can fail. When it will get alerted, who will be notified? You can simply enable your SNS. That's it. SNS will simply alert it via an SMS or email or any alert mechanism, whatever it has that provision. So likewise, right, use case can be complex to simple and anything that you wish. But again, it depends on how you choose your AWS services is very important and critical. It's not that you always need to have all the services, guys. Only necessarily whenever you want to have that service is actually required, you just want to simply orchestrate it and then you can just play with it. Okay. Any doubts, guys, here? Yes, you will have challenges, couple of challenges while doing, doing a POC or POV, or at the time of doing completely. But it's worth to do it. It's very challenging. You don't want to wait anything, to do only in your company. You can just simply log in, set up your account in your local machine, as I shown you, right? As like mine, you can just have all the services simply create it, and you can test it one time, and then prepare this use case in your machine itself to understand whether the expected output is actually generating or not. You can play with it, no doubt on that. Any doubts, guys?
Yeah,
Yep.
you said Athena, right?
Yes,
Athena, like, do the analysis on top, right? What is
on
the
top of S3.
on
Yes.
top of S3? Okay, what is the real use case? Like, it's like a dog execution, or can we still able to automate the results, whatever the query
You
we are executing against S3?
see, basically the data where we are going to simply trigger an SQL query is the S3 data. That's what it is going to be, the one place where you are going to SQL. When it comes to automation, I don't think it is there in place to automate your queries accordingly. But you can still write your queries as per the requirement. But still, there is a provision in step function where you can have your queries ready in Glue. That's what this script is, right? What it will do, the Glue will prepare your automated script, guys. Okay. That script can be incorporated in your Athena to run the query. But please ensure that you are not running any complex queries, like you don't want to have like multiple joins or any such complex things. But Athena does not support on its own automated queries. The only way to invoke is via writing your automated query from Glue itself. So you want to use that Glue accordingly to have your automated query.
Oh, yeah. Thank you. And what happened to the results it returns, like in terms of automation?
It is just showing in the preview in the console, or even you can download it the result. Simple. It won't show it will, yes, it will still store it in S3 also. That is possible.
Oh, we can able to store back the
We
results
can,
in S3. Okay.
yes, absolutely. Yes.
And final question, the Redshift you said, right? That is also querying thing, or it's like
Yes.
database
It
itself?
is a data warehousing tool. It is a data warehousing tool basically, where when it comes to comparing Athena and Redshift, Redshift is more powerful in terms of your queries. Let's say Athena is not server, right? It is serverless. But whereas Redshift is server, whereas you want to create your own spectrum, whereas like, when it say like you, Amazon provides it. Amazon does it accordingly. Okay, you don't want to do anything on your own. Redshift has its own spectrum. Spectrum is nothing but cluster with required capacity to run your queries parallelly, because it incorporates MPP, massive parallel processing engine. Whereas in Athena, we don't have that provision. You just simply put a query, get the result, store it in S3, or download the result. Whereas in
Uh,
Redshift,
yeah, only one
yes,
difference I want to ask, like where the data resides, like still in S3 or
yes,
it's maintained
S3,
in Redshift itself. Okay. Okay.
S3.
Yeah,
Redshift
thank
is only for distributing your queries to multiple node and get back the result and store it into S3. That's it. To
you. Yeah,
speed up
thank
our queries.
Yeah,
Yeah.
thank you. And one more final question, like the EMR you said, right? It will
Mm.
spin up it will spin up the nodes automatically. The scaling up, not the spin up, the scaling up the nodes automatically. Like, is it still possible? For example, I see when you create
Mm.
the cluster, we have to mention like what is the capacity, right? Like one primary node and like
Yes.
10 or 15 core nodes and task nodes, right?
Yes.
Will it go beyond that also automatically if we select like any options, scale it
Yes.
when the data is like very huge in the sense, not in the
Very good
expected.
question.
Yeah.
Very good question. So there is a something called, we have excellent future, something called we auto scaling. So for that provisioning, scale up your resources. Where it will do is EMR will not do. You want to enable your auto scaling accordingly, such that EMR will scale up as per the auto scaling that you enable. You got
Oh, okay.
you go got
Okay.
Yeah, auto
Auto
scaling is
scaling.
basically, yeah, auto scaling is nothing but whenever the data demands higher, or whenever you want the resources compute or anything that you want higher, this auto scaling, right? See, basically it is nothing but a template where you want to define, like, at the max I want 2 resources, at the max I want 5 resources. Immediately it will not assign all the resources upfront. What it will do, as per your question, EMR, let's say like you have 10 nodes, okay? The moment it expects another 2 more nodes to be added, because of the Spark job, it is taking more and more input data is consuming, right? You want to scale up some more additional nodes. So how do you do it? EMR will not do it. Where EMR, when I say EMR will, sorry, EMR will not automatically do it. EMR will do only if you have enabled your auto scaling provision facility in AWS. That's what I was like about to say.
That enable thing, it's like available in the
Yes.
EMR, or we have to go through
No,
this
no. In auto
auto.
scaling, you want to choose the EMR. Yes. Not in EMR to enable auto scaling. It is the
Oh,
other way around. In auto scaling, you want to either select EMR or EC2. Only 2 options will be there. So
mm, yeah.
if you opt to choose EMR, the moment you create a cluster in EMR, whenever the demand says you want to have additional nodes, when this auto scaling is enabled, it just simply gives you another nodes without terminating your cluster, or without aborting the job. It simply gives you. That's what this auto scaling has been, very good actually, when it comes to resource perspective, when there is a demand.
Yeah, really, this is helpful. Thank you.
No problem. Thank you. Great.
Rajesh, I have a very quick question.
Sure.
You gave a simple use case. Yes. So I have a different use case, like
Mhm.
I have a mobile application, and there is a live data, like processing with some incoming streaming data.
Mhm.
So this lambdas can be like used with Kinesis data streams or Kinesis
Yes.
data warehouse. Is that possible? Because the Parquet
Ab-
that you said is batch processing, that has very limitations with like only for CSV or XML files. So how about streaming data? Is it possible?
Absolutely possible, because lambdas are not only restricted to only work with batch mode process. It is even I due to time constraints I was not able to show you like couple of good engineering use
Yeah, that's
cases
okay.
which
Yeah.
actually running in real time. Yes, absolutely, lambda is also, we can integrate with Kinesis to get all the real time streams. Yes, not only it is focused for batch, even for, yes, real time streams as well, because real time streams are the one where you will keep on polling all your data, right? Batch mode is absolutely no way. Even when something is going to abort, you going to manually see and then take the necessary action, but not in the case of real time. You need to be very very alert in terms of real time data. Let's say like Twitter, always the data will keep going on. So always, right, it is to ensure that who will do it here is lambda function will absolutely enable our other APIs to ensure that other services are actually working as per expected.
Thank you, Rajesh Khanna. I've been very electrifying and very energetic in giving such answers. Yeah, thank you so much.
Great, great. Thank you for having such kind of motivational. Thank you for your words.
Cool.
All right. Anybody has any questions? I think we are already running out of time. Apologies for that. I think the thing is, right, so we have like see, this is very simple. We have just showcase only 10 best tools. We are having more than 10 best tools also, but due to time constraints, maybe if possible, I can even take one more session with all necessary people involved here to have the same data engineering use case. Maybe I can also show you one real time sample as well in that session, maybe going forward in some days when we connect together.
Sure. Definitely, guys. So yeah, thank you. Thanks, Rajesh. It's really very good session. We were able to understand a lot of things. But yeah, as you rightly mentioned, we just doubled the time. We usually go for 1 hour, but it's almost 2 hours. But it's really
Apologies,
good.
Armugam.
People have stayed until last, and I'm able to understand a lot of things. So
Excellent.
that's really good, Rajesh. Yeah, definitely we'll have one more session as a meetup, as we discussed. Like we have a couple of plans, and yeah, so we are also planning some kind of a regular classes as well. If you guys are interested, you can ping Tamil Bhumi, and you can follow us. WhatsApp number is there, so you can follow us. And also I've like put Rajesh YouTube channel as well, which is RK Data Lab. You can follow. He's putting some really nice content there, like all latest what's machine learning, everything is posting. So definitely go check out there also. I'll put the same in the WhatsApp group also, so that you'll be able to go from there and then see. And I put the feedback form here. You can just fill your feedback of this session. And definitely upcoming weeks we have a lot of interesting sessions coming. So next week I just wanted to mention with you, we are planning with one women's session, like women's tech meet, not tech meet, women's meet. We wanted to host one meet for only women, where they're the only panelists. Audience, anybody can join. It's not only related to restricted to women. Anybody can join as audience. So that we wanted to announce in this session itself, so that you'll aware and join. So thanks, Rajesh. Thanks a lot.
Thank you, Armugam. Thank you all for having this session to make more interactive. And once again, apologies for having double the time that we wait. But absolutely, it's very good. Having investing our time understanding the latest technologies is absolutely good. Thank you so
Yeah,
much,
it's
guys,
worth it.
for your active
Yeah, thanks,
participation.
guys. Thanks for the audience, especially you guys for still stay there for long times and understanding and following up. Thanks a lot, and happy Pongal, everybody.
Happy Pongal, guys. Thank you, Armugam.